Hey guys, today we are going to discuss this problem. It's a 1900 problem. It's really interesting. The solution is really interesting. So let's take a look. So as always, this is the example here. Um, so the problem is give you a guitar, and this guitar has 6 strings. And you are going to play these 6 notes with the 6 strings, right? So you have 6 strings here, and this is the original note the strings can play. And this is the number of notes you are going to play with these strings. And these are the notes, right? For example, you can play this note with any of the streams. So if you choose this stream, because this stream's original note is 1. So if you want to play 101, you need to use fret 100, right? Because fretting the fret number J on the ith string produces the note AI plus J. So this is array A, and you are going to use fret 100 if you want to play 101 on the number 1 string. And if you play this note on the second string, which original note is 4, you are going to need a fret 90, let's see, 97, right? So on and so forth. So, so you are going to play these notes with one of the string. And eventually you are going to have a list of fret, right? And you need to make sure that the maximal fret minus the minimal fret is the minimal, right? So what does that mean? So clearly, let's take the second test case as the example here. So clearly, if the stream's original note is the same, for example, these two, um, the second one doesn't matter. We can just deduplicate them, right? And so as the nodes, if the nodes are the same, we only need to choose a stream for that node once, right? We don't need to choose different stream for the same node, right? So we can easily just deduplicate these two arrays. So after the duplication, we are going to have the original array here, 1, 2, 3, right? And the note we are going to play here in ascending order, right? 4, 11, 12, and 13, right here. So how let's say if we want to play the first note on string 1, we're going to have fret 3, right? 4 minus 1 equals 3. If we want to play 4 on string 2, then we need a fret 2. If we want to play 4 on string 3, we're going to need a fret 1. So the problem translate into given a two-dimensional array here, we are going to choose one number from each row, right? For example, let's say we want to play 4 at the third string, this one, right? We are going to need 1 as the fret. And if we choose play 11 on string 2, we are going to use fret 9 here, and so on and so forth. Let's say we choose these 4 frets. Then the difference between the maximum fret and the minimum fret is 10 minus 1 equals 9, right? This selection is not good enough because the optimal is 7, which means we are going to choose which frets. Let's say we are going to choose this fret and this fret and this fret and this fret. So the maximum fret is 10. The minimum fret is 3. So the minimal difference is 7, right? So we translate this problem into choose some of the numbers for each row in the two-dimensional array. So which numbers are we going to choose? We're going to use a really interesting solution here. So we are going to have a set, right? And the set is going to save a pair of values, right? The first value is the fret here. And the second value is the index of the string. For example, this fret is using the third string, right? So if we are going to save this node into the set, we are going to save it as 1 and 3, right? So on and so forth. So what are we going to do with this set here? So what we are going to do is to first, we're going to choose our first selection, which is choose all the biggest frets and insert them into the set, right? So these 4 guys are in the set now. So if we choose this selection, what is the minimal cost? So it's 10 minus 1 equals 9, right? And it is really easy to calculate that because for the set structure, it has a API to get the smallest number and the API to get the largest number, right? So the difference is really easy to calculate. And what we are going to do next is to find the smallest node in this set, which is this one, right? So because we already choose the biggest numbers in each row, so if we want to decrease the current difference, the only thing we can do is to make the smallest number bigger, right? Because we cannot make the biggest number smaller. Actually, we can also do that. So we can make the biggest number being smaller. Oh, actually, we cannot do that. Sorry about that. I confused myself. So currently, we are choosing the smallest number in each row, right? So they are the smallest number we can have for each row in the set. So in order to decrease the difference here, the only thing we can do is to increase the smallest number in the set, but we cannot decrease the biggest number in the set because the current number is already the smallest, right? So the next step is to remove the smallest number and then choose another string for that number. So for now, we have 2, 8, 9, 10 now, right? It's better than just now because the current difference is 8. 10 minus 2 equals 8, right? And then we go on, find the smallest node in the set, which is this one, and replace it with a bigger node, which is this one, right? Now, still 4 nodes in the set, and the current cost is 10 minus 3 equals 7 now. And what is the current smallest node is this one, right? If we remove this one, we don't have a replacement anymore. So that is our optimal answer. So I guess that's it. So we run this iteration, and eventually we're going to have the optimal solution. And let's take a look at the code here. So the code is pretty easy. So first, read all the streams, and then read the number of nodes, and then read all the nodes, and insert the minimal fret for each node, right? We insert the minimal frets for each node. And then we are going to, this is our first cost, right? And we are going to do that iteration. And in each iteration, we are going to remove the smallest node and insert a new node for that removed node and calculate the answer and update it, right? And that's it. So thank you for watching. See you next time.